Bismillah, alhamdulillah, salatu wassalamu ala rasulillah ma ba'd. Hey everybody. So hopefully everyone is okay. So today I'm going to talk to you about the little basics of exploit research. So I'm going to talk to you about the buffer overflow vulnerability. So in this tutorial, I'm going to exploit this little application which is called Minishare. So you're going to be familiar with how to check out for vulnerabilities. If a given application is vulnerable to buffer overflow, you're going to actually learn how to create your own exploit, and in order to get a shell, either if a bind shell or a reverse shell remotely. So let's begin. So as you can see here, the application is running, and let's pivot here. Let me pivot here to another the Kali Linux, another VM instance, and let's actually run Minishare against this IP address 0.3. So I've ran the exploit, and as you can see here, nothing happened. Okay, the application hasn't crashed. Okay, let's open up the task manager. As you can see here, the CPU is normal, and we've got one connection here. Okay, as you can see in the bottom of the program here, right, left, it says one connection open. So if we go ahead and do netcat over to 3 on port 4444, which is the default part of the Metasploit framework, we pretty much end up with our getting a shell. Okay, host name. So as you can see here, if we go to Windows XP, run a command line here, ipconfig, we pretty much end up with the same result. Okay, so let me show you how to exploit this vulnerability and how to check if this indeed is vulnerable to buffer overflow. So at the end of this program, of this video, I'm going to show you how to customize or to improve your exploit. So for example here, the application is running, but after hitting exit, as you can see here, the application has crashed. So we cannot actually go ahead and exploit it again, okay, until the we're going to wait for the user interaction. Okay, so this is bad. So I'm going to show you how to customize your exploit, okay, how to improve it. I'm sorry, how to improve it, not customize it, because we're already customizing our exploit. So let's begin. So as you might notice, these series or these videos are going to be great, my friends. So please follow me along and practice along with me. So let's begin. So I'm going to create an exploit, a file called exploit here .py. I'm going to create the shebang user bin env python. I'm going to import the socket module, and from sys I'm going to import argv. Nice. So let's create the skeleton file here. So I'm going to create the socket instance, and this socket, the family I'm going to use is inet, and the socket type is stream. You can actually add a 0 here for default port, which is TCP, but you can get rid of it. So since we've got let's create the EDDR we're going to connect to. So here it's going to be argv1, which is the IP address, and the port number is 80. And let's try to connect to the EDDR. Once connected, let's send a buffer. And the buffer is nothing but a GET request. Okay, percentage is HTTP 1.1 and \r/n/n, and here we're going to provide the pattern, and the pattern is nothing but our buffer, our garbage data here. So I'm gonna send 1000 A's here first, and if an error occurred, all kind of exceptions as error, I'm going to print out the error. So that's our skeleton file. So let's go ahead and run this application into Immunity Debugger so we can perform some analysis against it. So that's how the program is laid out in memory. So let's actually, as you can see in the bottom here, it says it paused. Let me hit F9 to start it. Now it's running. Let's go ahead and Python exploit 172.168.4.3 and Vim stream. I've got a problem here. I'm bad in typing. I should learn typing. So the export has started, and now as you will see here in the bottom of the program, you will see that we've got a connection. One connection. It's not yet happened. So let's wait for it. So as you can see here, my friends, a connection happened, but nothing, actually the EIP hasn't been overwritten, which means the application is not yet vulnerable to the buffer overflow vulnerability. So let's try to increase the pattern. Let's put it 2000. Let's Python exploit, and let's hit Control F2, restart the tool. Let's hit F9, and let's start the exploit again. Well, we didn't get a connection yet, so we're gonna wait for it. So you can see in the bottom of the miniShare little window, in the bottom here, you will see one connection open. Once that happened, you're gonna see that the EIP would be changed here. So indeed, our ACE has overwritten the ESP register as well as the EIP register, which means we can actually somehow can go ahead and make use of this EIP to call our exploit, our shellcode. And as you can see here, the application has crashed, access violation when executing 41. And 41 is nothing but the hexadecimal value of the letter A, okay? So now in order to, what about actually loading our shellcode into somewhere in the application, send our shellcode on the buffer we're gonna send, and somehow actually we can go ahead and call it from the EIP, since the EIP would execute the next instruction, or this is the extended instruction pointer, okay? So an idea here, what you are going to notice, a couple of A's are laid out in the ESP register. So if we kind of go ahead and actually put, instead of putting A's here in the ESP, we're going to put our shellcode, and then we can go ahead and call it from the EIP itself, okay? That's it. So let's go ahead and try to customize our exploit. So the next step is to find the exact offset of the EIP. I need to make little changes to the EIP register. So I need to find the exact offset or the exact location of these 4 bytes. In order to do so, I'm gonna use another tool called, let's go to user, share, Metasploit tools. I'm gonna use something called pattern create. Let's create a pattern of 2000. So let's get rid of all these A's. So we've got our pattern here. Let's copy it, and after that I'm going to use another tool called pattern offset to identify the exact. So let's copy it here, the exact offset. Now let's rerun the exploit after restarting the little application. Let's run it, and let's hit enter here. And we are going to check out the value of EIP and give it to the pattern offset program. So as you will see here, we're gonna get a connection. So as you can see here, we've got 36, 68, 43, 33. 36, 68. 36, 68, 43, 35. This is the value that overwrote the EIP. So it's gonna give us the exact location of the EIP. So let's check if our calculations are correct. Let's remove the pattern, create it again. A couple of A's multiplied by this little value plus 4 B's, which would override the EIP, so 42 multiplied by 4, plus a couple of C's, okay? Say 200. Let's restart the application. And let's hit enter here, run the exploit. We cannot call it exploit yet, but we're still performing stress testing. So let's wait for it to get a connection here. So as you can see, my friends, indeed the EIP has been overwritten with all B's, 42, 42, 42, and our C's are laid out on the ESP. So now what I'm gonna do, I'm going to create a shellcode. I'm gonna load it into the ESP itself instead of these C's, and I'm going to jump to, from the EIP, I'm gonna add an instruction here, jump EIP, or give it the address here of the ESP, and actually the EIP would jump to the ESP, it would find our shellcode would be executed, would get executed. So that's great. Let's do it. So before doing so, let's go to exploit, make changes to it. So now what I need to do is I'm going first to create my shellcode. So I'm going to use MSF venum -p -p Windows shell. We're going to use the interpreter later on. Shell bind TCP -fc-a x86. And before generating our shellcode, my friends, we have to be aware of something very important in exploit research, which is identifying bad characters. So what is a bad character? A bad character is a character that is used by the application and could corrupt our shellcode. So our shellcode would be useless. For example, the null byte 0x00 is a bad character according to this application, because this application actually would actually, if it's gonna find a null byte, it's gonna actually consider it as a string terminator, and it would terminate our shellcode if that particular character is on our shellcode. So how to identify bad characters? This is very important. So you can use actually a script on the immunity debugger called Mona script, but I'm going to show you how to do it manually. So what I'm going to do here, I'm going to exit this tool. I've created a simple script here, vim bad characters. So this is a little script that would generate for us a set of characters. So we're going to execute it. This is the set of characters. And I already know that \x00 or the null byte is a bad character. So I can actually go ahead and get rid of it just to do not waste time. So let's put here our set of our characters set. Let's remove the null byte, and we're going to check, run the exploit against this little address. Okay, connection reviews, because we haven't started the tool yet. Let's send the pattern on the buffer, and we're going to wait for the connection here. Come on. So as you will see, my friends, now we've got a couple of A's, okay, above, and then we've got B's, and we've got 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 7, 8, 9, A, B, C, and there's no D, which means 0D is a bad character. So let's go ahead, restart the tool, start it again. Let's go here and remove the 0D itself. So I'm going to get rid of it. Let's send it again. And as you can see here, we're going to check out, we've discovered a bad character which is 0xd, 0 or \x0d. Now let's check out if there is other bad characters. So we've got one connection here. Come on. Okay, we've got it. Now let's follow up our little pattern. So we've got EF. So 0, 1, 2, 3, 4, 5, B, C, E, F, 0, 0, 1. Okay, we've got our set of characters up to the FF, FD, FE, and FF. So now all the remaining characters are good for us. Okay, so now we are going to go to the MSF Venom, tell it that we are going to avoid some bad characters, and those characters are 0, 0, 0D. That's how to do it. So there is a very important part that you need to understand about Metasploit. Metasploit, the default exit function is exit process. So if you notice, we are going to use this shellcode. Okay, let's create our shellcode here. Let's copy paste it. 178.1787. Okay, so let's actually now try to find out the address of the, let's send, okay, I'm gonna send B's as always and a couple of C's multiplied by, or before doing so, we already know that this shellcode would be laid out on the ESP register. I'm not gonna call directly the ESP memory address, but I'm gonna go to executable modules, and there is a DLL files here. You can actually go ahead and hit Control F to find something, an assembly instruction called jump ESP. So as you can see here, this is the address related to it. So 53.93.3a.7e, 53.93. So I'm gonna put it here. EIP is equal to \x 53 \x 93 \x 3a \x 7e. This is the little memory address. So what I'm going to do here, simply put, I am going to concatenate it with the EIP and then our shellcode. So if we think about it, our shellcode here, this is the exact offset of the EIP. So it would actually go ahead and call this little memory, which is jump to the ESP. Once the application hits this little location, it would find an instruction called jump ESP, and the ESP is pointing to our shellcode. So since our shellcode is pointing to the beginning of the ESP, in order to avoid overwriting the first bytes of our shellcode, we are going to add here some nopslat, \x19 multiplied by 8, for example. And what are all nopslat? Nopslat are nothing but an instruction that does nothing, no operation, okay? Does nothing. It will actually jump to the next byte, etc., up until it found our shellcode. So let's go ahead and Python it again. So our application is not running. Let's restart it. Let's hit F9 to start it, and there you go. Let's hit let's vim exploit. We've got a problem here. Sorry, my friends. So let's print try to open a shell, or try to connect to port 444 on the remote host. Victim machine. So let's actually try to connect to port 444. It's netcat. And if we go here, as you will see here, we haven't yet got a connection. We're going to wait for it. As you will see here in the bottom, you're going to see one connection open. So as you can see here, one connection. If we go ahead and do netcat 444, indeed we've got a shell. ipconfig would end up giving us the IP address and a little information about the TCP IP configuration. And there you go. But if we hit enter, simply put, you're going to notice that the application has crashed. Okay, let's go ahead and improve our exploit. In order to do so, I'm going to simply put here something called exit func is equal to thread, not process. Okay, and you're going to notice how our shellcode would be very, very smart. So let's copy paste it. Let's go here, vim exploit, get rid of our shellcode here, shellcode, and there you go. Let's run it again, connect your reviews, because we haven't started the application yet. Let's hit enter, and we should get a connection here. But now, after exiting the shell or the bind shell or the session, the application wouldn't crash. Okay, wouldn't be crashed. We'll never actually crash after exiting our machine. Okay. Let's go back here, try to connect using netcat. We haven't yet got a connection. I don't know what the problem is. So let me run the application without Immunity Debugger. Let's hit enter, run the exploit. We're going to wait for the connection here. Okay, come on. And we still didn't get a connection. Okay, but we've got a little crash. I don't know why. Let's run it again. Let's check out the exploit itself. So we've got a simple and finally, let's go ahead and s.close. Okay. Let's wait for the connection to be happened. Let's try again. Come on. So I don't know what the problem is. Let me pause the video. So my friends, the problem was actually on the NOPSLAT. I've changed it, as you can see here. So we've got a shell here, and now if we try to run ipconfig, for example, and exit the program, as you will see, the application wouldn't crash. Okay, it's not crashing. So let me hit exploit here, and as you will see, I've added some NOPSLAT here. Okay, that's the reason why our shellcode has crashed. Okay, or hasn't been executed because of the NOPSLAT. So you are going to add some NOPSLAT, so the first parts of our shellcode wouldn't actually be overwritten. So that's how to a little introduction and the little basics about exploit research and how to discover if a given application is vulnerable to buffer overflow. Hopefully you like this video, my friends, and just go ahead and go ahead and generate a shellcode with, Meterpreter reverse TCP and try it out along with this exploit and check if it would actually work for you. And by the way, the operating system I'm using here is Windows XP Service Pack 3. Okay, it's the property, as you can see here, Service Pack 3. So thank you for viewing this video. See you next time.